I'm Lee Carlson, graduated from NJIT in 2004 in mechanical engineering. I started working for Honeybee that same summer, and I've been here ever since. This is my SMS teammate, Mike.
Mike Passaretti, NJIT class of 2005. Started working for Honeybee Robotics in January of the same year. Majors computer engineering, currently pursuing masters in engineering management. Honeybee Robotics is one of the world's top developers of advanced robotic systems. We are an R&D engineering service company that creates solutions for our customers' unique and challenging problems. Today I'm going to talk a little bit about SMS, which was one of Honeybee's contributions to the Mars Curiosity rover.
SMS sits at the heart of NMSL's key science payload, which is SAM. It's designed to look for the habitability of Mars or the Martian environment on or below the surface of Mars. Curiosity rolls across the surface of Mars collecting samples. Those samples are handed to SMS, which is where we take over. We move these samples from a collection point to one of three different science stations. Sample handling on Earth is pretty easy. You hand it to your lab tech, he runs it over to your science suite, takes the measurements you need. On Mars, you need a robot to do it. It would be hard enough to get a robot to do that here on Earth, let alone 350 million miles away. So there were many challenges involved with creating a mechanism to replace a human for this task, and somewhere along the way we had to get some electrical engineers involved, and that's where Mike participated.
So my involvement on SMS was mainly acting as an electrical engineer. A big part of my job was designing the electrical harness that's used to power all of the motors and the various sensors that allow SMS to function, determine where its samples are, and where they need to go, but also to tell the rover when the SMS is doing its job. The SMS electrical subsystem was designed mainly in a product now called Alum Designer. It's a suite of software tools available to electrical engineers. However, we mainly just use the board layout and schematic capture parts of the program to design the SMS electrical flex tape, but also the optical switches, which are responsible for telling the rover where the SMS carousel is positioned.
One of the parts of SMS was just the rotating carousel assembly. You create a breadboard first of just the rotating mechanism, and another breadboard of the elevator mechanism, and another breadboard of the harness. You test them all separately so that you can prove their worth before making a more complex system out of them.
Right, so breadboards are very useful in mitigating risk in a design. So as Lee just mentioned, there was several complicated different things that we had to figure out to make SMS function as a whole and meet all its requirements. Each one of those problems combined together is really hard to figure out, but if you break it down into smaller chunks and breadboard each one of those, you can solve those problems more efficiently and be less worried with the clouded, more complex problem that is the whole system. Working on projects like SMS or any complex aerospace project really points out how important it is to have people with a variety of technical expertise in areas like science, technology, engineering, and math. These are the careers that will build the future.